obviously, but maybe it needs about the eval expression, because we're in the middle of that. So yeah, you need to know about selection sort, you need to know about heap sort, yes. You need to know about recursion, yes. You need to know about the stuff we've done on runtimes, yes. But that would be it. Do you have questions for me? Now again, the test will be in two parts. You'll be taking the first part on paper. You'll hand in a piece of paper with your work on that. And then at that point, you'll be programming something. I may give you a choice of things to program that'll be worth different points. One will be a little bit harder. One will be a little. I'm not going to make the hard one real hard, but if you don't like the looks of that, you can lose a couple points and work the easier one. So there will be two programming problems you can work, and of slightly different point counts. And you pick one to work. So the one with a slightly smaller point count will be worth slightly less. Okay, so you'll have a choice of programs. And you'll get to see all this, when I pass out the test. Okay.
Are you still going over a little bit of recursion this morning?
We could do some recursion. Yeah. Should we do some recursion? Yes.
Is eval exp going to be on the test?
No.
Not really.
No, we really haven't gotten very far in that. So no, the eval expression will not be on the test.
All right.
Other questions? Yes.
I don't know if it was in the syllabus, but just out of curiosity, how much are the exams weighted in our overall grade? Do you know?
Yeah, it says in the syllabus. I don't have the syllabus here. If somebody's got it, you can check it. So I'll follow that. If for some reason we need to modify that, I won't make it worth. I don't think I want to make it worth more, possibly less than what it says there in the syllabus. So I don't know. Maybe you've got the impression this is going to be worth 100% of your grade. No.
No,
Yeah.
I just didn't know.
Yeah. So it's significant, and you ought to.
I didn't know if you were doing like this one was like 25% and the final was 50 or.
Yeah. I forget, but it says it there, and you've got a copy of it.
Yeah, I'm looking at it. It says tests in total is going to be 45. You said there's two?
Yeah, there'll be a second test,
Okay.
and then there'll be a final. Yeah.
Should be like 22.5.
Right. Yes. And so, that's not even quite true that they'd be equal. What's going to happen is we'll add up whatever score you got on this one to whatever score you got on the next one, and divide that by the total possible points on those two. And that's your test score. So, yeah. So you have the score on test 1 plus the score on test 2 divided by the total number of possible points on test 1 plus the total number of possible points on test 2. So that will be your test average. And so that's worth what, 40, 45? That seems like a lot, but okay, so that's what I said at least. Okay. And the final's worth what? Was it 20%? Maybe it was worth only 15.
Final is 15.
Yeah. Okay. So this would be the test average, and then we'd have the final, which would be whatever the total on the final divided into your grade on the final. So the total on the final divided. So all of these are going to be figured as percents. So you do the division and multiply by 100, right? That's how you do percent. So we've got the test average, we've got the final, okay. And then there's programs, and we're going to have a few more programs. Recursion, right? So, someone mentioned recursion.
Well, you said yesterday. you were gonna
Yeah, well, we could
Briefly.
we could look at some problems there. What would be a good example? Well, a very early example of recursion was we had an array, A, index 0, 1, 2, up to some value. So this is array A. And so we did something like this. So that we've got this array A, and here's the recursive function, void PRT int I. And if I is less than 0, we just return. And otherwise, we're going to print out. So I'll actually put in a printf here. And then, so we're going to do, we have 3 lines. We have this if, we have this print, and then we do PRT parenthesis I minus 1. And close brace. So let me be specific about what we've got here. Maybe I've got a 7 and a 10 and a 4. 22, 57, so let's see, I've got index 0, 1, 2, 3, 4, let's put one more thing in here. At index 5, so this is a 52, and then maybe a 77. So I've got, this is recursive, this PRT is recursive, it calls itself, right? And say we call it, so inside of main, we say PRT parenthesis 5. And then the question is, I've given you this recursive function, what prints? So you come in, you check to see, is I less than 0? Is it less than 0? No. What's the I? The value for I is 5. So we don't return, we come down here and print. What are we going to be printing? We're going to print out A brackets I. Okay, so this call, then, our first call, the value for I is 5, and we're going to print out what's in position 5, which is the 77. So on the screen, then, so this is our first call, call 1. We're going to print a 70, so on the screen then, a 77 prints out, and now we do this recursive part here. So we're doing a second call. So this first call isn't finished, because for the first call, before we have 3 steps here. This step, this step, this step. Call 1 has done this step. We check to see is I less than 0. If it was, we got to return. It's not. Then we print it, And so right now, we're stopped in step 3. We're doing this recursive call. When we return from here, when we return from step 3, then this call will be finished. What the computer does is the computer kind of stacks these calls. So maybe I should make it look more like a stack. So here's this first call, call 1. And so I is a 5, and we're stopped in step 3, and this is call 1. And what are we doing? We aren't going to finish till we return from that. So we're doing a second call. So main makes the first call. This first call does this step and this step, it stops here. It's waiting for, I shouldn't say stop, it's waiting for this call to return. That we're going to run this second call, call 2, and now let's see, I is going to be 4, right? Because I'm plugging in the I here. Each of these calls has its own local variable I. And so we're going to have then, so I'm plugging in I minus 1, so this thing right here is the I of my first call. So I is 5, but I minus 1, I'm plugging in a 4. So this is also the code for the second call, where there's a 4 being plugged in. The value plugged inside the parentheses is I minus 1, so that's 5 minus 1 or 4. So a 4 is being plugged in, so the second call has I4. It checks this. It doesn't return because it's not listening. It prints. So it's going to print out a 52. And it's going to be stopped in this third. It's going to be suspended in step 3. It's not quite finished yet. And it does a call. It calls this function yet again. What's being plugged in? Well, our current I is 4. I minus 1 would be 3. We're plugging a 3 in. So call 3 is going to have I being 3. We're going to carry out these 3 steps. We don't return. We do print what's at index 3, which is a 23. And we temporarily stop. We're waiting for the next call to complete. So we now have call 4. What are we plugging in to call 4? I minus 1. Well, I is 3, so I minus 1 is 2. So the value inside of call 4 each of these has their own I. They're in completely separate places. There's no confusion. The computer stacks these up. There's an area called the stack. Okay, so now that we're starting call 4, yeah, I is not less than 0. We print out what's at index 2, which is a 4. So a 4 comes out on the screen. And we're stopped in step 3. And so what's happening then is we're calling print again, and we're calling it with I minus 2. So here we are back here at call 4, and I'm plugging in so that's 2 minus 1, that's 1. So call 5, I is 1. And we go through these steps. We'd like to return, but we can't because we're not less than 0. We're going to print out what's at index 1. And what's at index 1 is the 10. And then we're going to suspend here. So I'm running out of room. So stacked on top of that, then we're doing call 6. And what's being plugged into call 6? Well, we have back here at 5, I is 1. 1 minus 1 is 0. So what's being plugged in is 0. We check, is that less than 0? Unfortunately, no. So we're going to print out what's at index 0, which is the 7. There it is. And we're going to do another call. So fortunately, I think this is the last one. What are we plugging in? I minus 1. Well, I is 0. So we're stopped here at step 3. Each of these we're stopped in step 3. So 0 minus 1 is minus 1, so the I here, this is call 7. This is call 7, I is minus 1. So if I is less than 0, return. Thank God it is less than 0. So we're going to, so call 7 finishes, it doesn't do another call. How long does it take the computer to do all this? Its function calls are very fast, so this takes no time at all. So call 4 finishes, and we return back here to call 6. So here we are, now we're in call 6. Did we do anything after we just finished step 3. That was the call to, that was the seventh call to this print function. So we just finished that. Well, there isn't anything more. So when you fall off the end, that's a return back to here. So here in call 5, we were doing this thing here, which was the call to 6. We just returned from there. So we're going to return. And so this is the result. Okay, so this is not terribly exciting, but say we swap these two statements. So almost the same. I don't want to do it so large because I don't want to. So this is void, I'll call it PRT2, parenthesis, int I, open brace. And so this first part's the same. If I is less than 0, then we're going to return. Question? And then I'm going to swap these two. We'll do the recursive part next. So PRT I minus 1. And then we'll print down here. We'll print quotes %d \n in quotes, comma, a brackets I. Okay, and so this is the PRT2, and then we're going to have main. So right over here, int main open brace PRT2, but I don't want to put a 5 in it. That took forever. Let's go with just a 3 here. So let's run that. Where can I run it? So I'm going to erase this one here. So just swap those two statements. That's all. That's the only difference. So main makes the first call to PRT2. So this is call 1 to PRT. So all of these are going to be calls to PRT2. So what happens, what's the plug-in value? I'm putting a 3 here. That's going in for the I. So I is 3. Now what happens? So we still, this is 1, 2, 3. Is I less than 0? No. So we aren't going to get down to this print right away because the call to, this call 1 immediately does what? In its second step here, it does another call to, this is supposed to be PRT2, sorry. So PRT2 calls itself. So here's call 2 to PRT2. And I'm plugging in I minus 1. Well, what's I? I is 3. I minus 1 is 2. So the I for call 2 is going to have a 2 in it. And what's going to happen? So in both cases, so here we got stopped in step 2. And here we're suspended here again in step 2. We have, so this is our first call, and we're stopped in step 2 where we make the second call. Here's the second call. The second call is going to be stopped while it's waiting for the third call. Call 3. What are we plugging in? I is 2. 2 minus 1 is 1. So the I here is 1. 1 is not less than 0, so we don't get to return. And so we're going to be stopped in step 2 and you'll be doing another call up here. So this is call 4. Have we printed anything? We printed absolutely nothing. What's the value for I here? What's getting plugged in? I've got a 1 here. 1 minus 1 is 0. So I is 0. 0, that value for I is not less than 0. So we don't get to return. Instead, we're going to be stopped in step 2. And so we're going to have call 5. Thank God this is the last one. I is 0. So what are we plugging in here? We're plugging in 0 minus 1. So the I up here is minus 1. So what's going to happen now? We're stopped in, we are, okay, so I is minus 1. We're going to, if I is less than 0, return. Well, I is minus 1. So we're going to return. We're going to return back here to step 2. That means this step 2 is over. We've returned from it. Here we are in call 4. It made this call, and we've returned from that call. So step 2 is finished. What do you do after step 2? You go on to step 3, which is what? Print. We're going to print out what's at A brackets I. We're going to print out what's at index 0. What's at index 0 is the 7. So on the screen then, at this point, the 7 prints. And that's the last step here. So after this call is finished and we return to here. And so we're returning to step 2. We've just finished step 2. So we go on to step 3 with this I. I is a 1. We're going to print out what's at A brackets 1. That's the 10. And now that we've done the printing, that's it. So we return to this here, I is 2. And so we've returned to, we've just completed step 2. So we're going to print out, we're going to go on to the next step, which is step 3. We're going to print out what's at A brackets 2, which is the 4. And then that's it. So we're going to return to here. We've just finished step 2. Well, now I is 3. We're going to, we just finished step 2, so we go into step 3. We're going to print out what's at A brackets 3, which is the 20, what is it, 23. And so we've just completed this, okay, so we returned and printed that, and so now where do we return? Well, this call came from main, so we return to this. We go on to whatever comes next in main. There isn't anything, so we get 7. So notice, the first way of doing things, we printed from the right back to the left. All we did was we swapped these 2 lines, and now we're printing from what? The left to the right. So this is a kind of typical problem where what am I asking? I give you the function and ask you to tell me what prints out. So I won't give you this one, I'll give you something else. And notice that a very small difference here, you get quite a different result. You're still printing numbers from the array, but you're printing them out. In one case, you're printing them out left to right. In the other case, you're printing them out right to left. Take a look here. Here, with this order, you have to finish all of the other calls before you do this. So, what does that mean? That means I've got to finish, and what am I doing each time? I'm plugging in a number that's 1 smaller. So before I can print this out, I've got to print out, I'm going to have to print out all the other numbers that are further to the left. So this stuff with the stacking, and then so you have multiple copies of the function. What's on top of the stack is what's currently active. When we return back to here, this is gone, and now this is active. When we return from here back to here, this is gone. So these things stack up, and as we return, either from here or by falling off the end and having completed all 3 steps, these things come off the stack and we're back to the next one. So what actually has to be, we don't have to stack the code itself, we just need to stack the variables of the function. So each call has its own copy of the function's variables. Here, I guess this function only has a single variable. I've got an I here. I don't have any variables declared. But if I did have variables declared here, then those would also be duplicated. Okay. We could look at another example, or we could work on, this is a little bit up to you, or we could work on the eval, the expression. But that won't, I guarantee that will not be on this test. Yeah, on the next test, yeah, I'm thinking likely on the next test. There's that thing of the Fibonacci sequence. I'm just looking around for another example. It starts off 1, 1, and then you say 1 plus 1 is 2. You add up the last 2 things. So now the latest 2 things are the 2 and the 1. 1 plus 2 is 3. So now I'm going to take these 2 things here, the 2 and the 3, and that's going to get me 5. So now the last 2 things are 3 and the 5. The 3 and the 5 makes 8. So this is called what, the Fibonacci sequence, and it comes up in lots and lots of different places in nature. It even comes up. It gets used in computer science in various ways. You start. You have a pair of starting values. You need a pair because you have to add them to get the next thing. Hi.
Do you mind if I try this?
Sure.
With Steve's images?
Steve?
Put it in a reboot and it starts to land.
Oh, no, that's nice.
I'll try it out while you're
Okay,
If it
so,
works, you make one for YouTube.
yeah, no, I'd like to have that. So, what about the code for this? Remember, so, I mean, this is a fairly typical pattern that you have some if that handles, so this, in this case, this function is going to be returning a value. So int fib, and so we need a place to get started. So let's say that the 0th Fibonacci number is 1, and then Fibonacci, so the 0th number is 1, the first number is 1, the second number is 2, the third number is, it looks like there's a pattern here, except the 4th number is 5 and the 5th number, okay. So, in. So, how do you find this? If you want to find the nth Fibonacci number, so I've got a question mark here. Here's the nth Fibonacci number, and I want to find it. What's the pattern? You want to add up the previous 2. Okay, so what I want to put down here is what? I want to return. So I'm in place of printing things out, this function is returning a value. What value am I going to return? This is the nth number, Okay, so I want to know what the nth number is. How do I find the nth number? I take the previous two numbers, add them up. You know, whatever this is and whatever this is, I add them up. And so what, you have a formula for the previous number? Yes. What is it? It's fib, yeah, fib n minus 1, right. Great. And then what about the number before that? That would be n minus 2, right? Okay.
How long did it take? 3 minutes to boot or something like that?
That's not too bad. That's pretty nice.
We have extra ones. I'll ask them to make one
Yeah.
for you. You would, what is this, 201?
This is 201.
Yeah. You have 202 in here as well?
No.
Some other place?
Yeah, yeah. No, this is all I've got here.
All right.
Yeah, yeah, okay. So just plug it in and it comes.
Root authorization required. Whether that matters.
Oh, so it really does. It looks just. Do I have access to my files?
Yeah, I think so. Should work. If you want to try it, you can,
Yeah.
after class, I'll leave it.
Sure. Okay. I should bring it back up.
Yeah.
Okay. So we're going to return here fib n minus 1 plus fib n minus 2, right? But we don't always do that. What about getting started? So 0 and 1, if n is 0 or if n is 1, what's the answer? The answer is 1. So how do we put up something like this? So in place of that, if n is less than 0, we'll say here if n is less than 2. So if it's either one of these, we're going to return 1. Let's try this out. So let's say I've got main here. And let's compute, I don't know, we'll compute fib of let's do fib of 5. I don't think that's too bad. So our call, our very first call, I kind of expect you to be able to draw this picture. We're going to have a call. Our first call is from main. Execution starts at main, fib 5. And so what's the n going to be? So this, we have a variable n. I'm plugging a 5 in. So n is 5. And do we return? Well, if n is less than 2, we return, but it's not. So what are we involved in? We are involved in 2 other calls. So we're going to have here, so call 2. We're going to have this call, fib n minus 1, so that'd be what? That's 4. N equals 4. And once we return from that, see, this is a little more complicated. I've got a plus sign here, so I'm going to have to find out what this value is, and then once I find out what this value is, I have to find out what this value is, and then I get to return, right? Okay, so I've got to find out what this is. And that's 4. Do I get to return? No. So we're going to put another call. I mean, so again, the computer is fast. This would be call 3. And it's n minus 1, so this up here would be what? N will be 3. And I need to calculate, so there's going to be call 4. And n is going to, maybe, so what's bad here is that this fib function calls itself twice. That's what's a little, I will avoid giving you one like that, okay? Okay, so now we're at n equals 2. I don't get to quit yet. Okay, so we're back up here to the next call. This would be call 5. See, 1, 2, 3, 4, 5. N is equal to 1. 1 is less than 2, so what's that one going to do? It's going to return a 1. Yeah, it's going to return a 1 here. So what's this one trying to do? I have two statements here. Sorry, statement 1 and statement 2. And I know that this is a 1. So now I know that's a 1. What do I? So I'm returning a 1. N is less than 2. I return a 1. So now we have to calculate fib of n minus 2. So I'm back to here, but I'm not through yet. What is n minus? N is 2. So we're going to make another call up here. This call 5 went away, but now I've got a new call 5, and that's where n is equal to 0. So I subtracted 1. That was this one. Now I'm subtracting a 2, and so that's going to return another 1. So this is 1 plus 1. 1 plus 1 is 2. That 2 is being returned down here. So this call where n is 3, and so we finished this. Now we have to do this. N is 3, so n minus 2 is what? 1. So we will get another call with a 1. That's less than 2, so we'll return a 1. So I'll have 1 plus 2, which is 3. That's going to be returned down here. But that's being returned to the fib of n minus 1. So we need to work now on the fib of n minus 2. So 4 minus 2 is 2. So we're doing a call where n is 2. So notice we've already done that calculation. Now we're redoing it. Okay, so n is 2. And so we need to calculate this and this. So that'll be fib of 1 and fib of 0. That's 1 plus 1. So those get stacked up, but that's coming back as a 2. So I have here then a 3 plus a 2. That's a 5. That's being returned down here. We're almost done. So here n is 5, and so this was the fib 4. Remember, it was 1, 1, 2, 3, 5, and 8. This is 0, 1, 2, 3, 4, and 5. So this was fib of 4, and so now I need fib. Remember, it's n minus 2. I need fib of. I refuse to do this. Let's see. Surely there must be someone that I could do. Not that bad. So fib is okay. I want to give you one that's more like what you'd actually get. Int s and n. So if n is less than 1, we're going to return 0, and otherwise, so I don't have to say it. We return this. If I get to here, n isn't less than 1. So what will we do? We'll return n plus s of n minus 1. Okay. So notice this involves just one recursive call rather than two. I would have given you this one, but now that I've shown it to you, damn it, I can't. Okay. So let's see if we can see. So here's main, int main So I'm calling S, let's not do it with a big number, we'll settle for 4. So maybe we want to print out that, so print F quotes %D \n end quotes, comma, this value. So we need to find S4, yes?
So what type of problem are you going over now?
I'm going over a problem like what will be on the test tomorrow.
Okay. But like, what type of problem?
This is a recursion,
Okay.
because this function calls itself. I need a semicolon here and there. Okay, so main calls this thing. So here's our first call 1 coming from main, and the value being plugged in is a 4, so that's going in to this parameter here. If n is less than 1, I get to return a 0. But I don't. Instead, I need to return n, which is a 4, plus this guy. So I'm doing a recursive call. So this is call 1. That's going to produce then a second call where I'm plugging in n minus 1. Well, if n is 4, n minus 1 is 3. So in call 2, I'm plugging in a 3, and so it has its own n, and its n is going to have a 3 in it. 3 is not less than 1. So call 2 is going to make a call 3, where I'm plugging in to here n minus 1. Since n is 3, 3 minus 1 is 2, so the value being plugged in is a 2. So the n going with call 3 is 2. Call 4, the n is a 1. That's not less than 1. So finally, we're way up here at call 5, and n is 0. Is that okay? Okay. So what about n being 0? Well, if n is less than 1, what do? We return 0. So what's coming back down here is a 0. That is, we have s, what we have here is s of 0. N is 1, so the formula here is 1 plus s of 0. S of 0, we just found out, is a 0. So the value for this is a 0. If n is less than 1, return a 0. Okay, down here, we've got s of 1, 2 plus s of 1. We have to evaluate this and return that. What's s of 1? We just did a calculation here, 1 plus 0. What is 1 plus 0? I think it's 1. So I've got 2 plus 1 here. We'll be returning that value down here. This is 3 plus s of 2. And so I'm going to have 3. What value is this? This was 2 plus 1 plus s of 1. S of 1. So this was 2 plus 1. This was a 3. I'm returning a 3 here. This is 3 plus 3. The value is 6. A 6 is being returned here. So I've got 4 plus s of 3. What's coming back from here is a 6. 4 plus 6 is 10. That's the value that's returning. A 10 prints out on the screen. What does this do? When I plugged in s of 4, what did we end up adding up? We added up a 0 and a 1. If I reverse it, 0 plus 1. Here we added up, and then here we added on the 2. Here we added on the 3. And here we've added on the 4. So we've added up the 1 plus 2 plus 3. We're adding up the first 4 positive numbers, and so we get 3 plus 3, we get the 10. So I would have liked to give you this one, but we just, I mean, in each case here, down here at the bottom, well, one of two things happen. Either we return a 0 or we return this. So here n is 4, so I'm going to have 4 plus s of 1 less. This is s of 3. Up here, n is 3, so I'm going to have 3 plus s of 2. Again, it's s of 1 less. So the value that, so we calculate this value here and we return it for this. Up here, we're doing S of 2, so that's going to be 2 plus S of 1. So when we calculate this, we'll have S of 2. Up here, we're doing S of 1, so that's 1 plus S of 0. And S of 0, if it is less than 1, we return right away. So that's why this S of 0 here is a 0. This value is being returned down here. It's 1 plus 0 or 1. So we're returning a 1 for this value here. Now I've got 2 plus 1, that's 3. That's being returned down here for this. I've got 3 plus 3, that's 6. That's being returned down here for S of 3. 4 plus 6 is 10. That's being returned. So this 10 is being returned to main. And so main prints out what S of 4 is, and so it prints out on the screen would be a 10. Does that help? So this, what we have in each, we have a copy. In each one of these calls, we have a copy of n plus S of n minus 1. So here it's 4 plus S of 3, 3 plus S of 2. So here the n minus, it's always 1 less, 2 plus S of 1, 1 plus S of 0. Now this S of 0, though, we don't have to use the formula up there because we check is n less than 1. It is, so we return a 0 right away. Okay, so I'll give you something like this. Or if I can think of a way that's a little simpler, but I don't count on it being much simpler than this. Okay. So recursion, runtime, so where I give you little pieces of code and you've got to figure out how many times does step execute. So the recursion, the runtimes, stuff from selection sort, stuff from heap sort. I don't know, I might pick out one or the other and not give you both. And then a little bit of program that you actually have to write and enter on the computer. You'll pay attention to what the name is. If it's, it'll probably be something like test 1, T1 point, if it's problem 7, T1.7.C. I will tell you what the name is. Don't call it something else. Because if you do, I won't be able to find it. Okay. So I can't make the test terribly long because you have to finish in 50 minutes. I'm aware of that. That you're just learning this material. But on the other hand, I mean, I'm not going to make it, completely trivial. Write your name. So somewhere between write your name and something that looks way too hard. I mean, I'm going to shoot to make it a reasonable test. It shows that you learned something. Okay. Any last minute question? We've got about 30, 40 seconds here. Okay, so I'll see you tomorrow at 9:30 in that other room.